factory for the
Opel,
cars.
the automobiles.
Yeah.
Ah.
Yeah. Yeah, that's the Opel City. It's
Okay. Very
known
good.
like this.
What's the most favorite place you've lived?
That's a strange question. I love all the places. I mean, I don't like to put roots somewhere. I love traveling all around the world and see different cultures, different people. I love nature. So everywhere where there is a lot of nature, I'm comfortable.
So how many continents then have you lived on?
I have lived just in Europe, but
just in Europe. Okay. But it sounds like you've traveled to a lot.
yeah, I was in Africa, in Asia. I wasn't in US, but it's on my list.
Never to the US, really?
No, never to the US.
What about 3D Experience World this year? Do you think you'll make it?
It's a complicated journey for me for 3D Experience because I have to finance it myself and it's not so cheap. But I would really love to go there and see
and
the people.
it's in my hometown this year. So
yeah,
I hope you can come.
Yeah, I will try maybe, but we'll see. I need some budget aside for that.
Yeah, for sure. It's not getting any cheaper to travel right now for sure. At least here in the US. I think that's a worldwide issue, isn't it?
Actually not. I mean, some countries were open a long time ago for traveling, especially when you're vaccinated. So
yeah. Cost-wise, though, our fuel costs are pretty high right now.
Yeah, that's the case. Fuel, electricity, but this cannot stop a traveler. Just can't.
So tell me about the first 3D printer that you bought or used, I guess, or learned how to use.
Oh, the first 3D printer, it has really a nice story. It was in my ex-company in which I was working, and because we do a lot of prototypes there, and they were always sending to some subcontractor to do it. They were expensive, they were slow. And one day I just told to my leader, why we just don't buy a cheap FDM printer and make the first prototypes, at least here, until we have a ready design, and then this to send to the subcontractors. And he said, oh, no, the cheap printers cannot print good. And I said, are you sure? Have you seen some recently? Then we went to a trade fair, and he was actually surprised that machines which are not 5 digits or 6 digits in price actually can print pretty decently. And a month later, I think we buy Ultimaker 2. This was actually my first 3D printer.
Ultimaker was, okay, nice.
Yeah.
So what was the nature of the parts you were making?
So enclosures for probes, for oscilloscopes. And yeah.
So they were small?
Not all. Some
Not
are
all?
big, but mostly are small.
How big did you print?
The biggest thing that I have print is like a phone size, but a bit thicker.
Okay.
Yeah, that was the biggest part and one of the hardest I have print.
So then you went from Ultimaker to what? Did you stay with that, or did you try out some other printers?
So actually I improved that. An engineer is always engineer. I changed it a little bit after it was out of warranty. I changed the cooling of the print. I add a second filament because it's implemented in the board, so it needed just a motor and extruder and such things.
No kidding. You put your own second extruder on the printer.
Yeah, why not? I mean, I can do that.
I'm going to have to learn how to do that.
It's working just only if the motherboard is prepared for that. And the Ultimaker was prepared for that because they were planning to launch a 2 extruder version of the printer.
That is cool. Yeah. Well, Wow. Well, Danute, it looks like we're time to go live here. So I'll just take a second to welcome everyone to SOLIDWORKS Live Design. We're here with Danute, who is joining us from outside Frankfurt. And this is going to be a really cool episode. I think we're going to have a lot of questions because I would guess that in the chat, we've got a lot of enthusiasts, a lot of SOLIDWORKS users, but who are also 3D printing enthusiasts like myself. I think there's going to be a lot to learn from Danute. She runs her own YouTube channel, D Workshop. You're going to need to check that out. I think we'll have a link to her channel here in the chat coming up, and a link to her LinkedIn profile. So you'll want to get to know her. But she's a freelance user of SOLIDWORKS, design engineer, a really interesting background, and she's going to tell us about designing for 3D printing. So Danute, welcome. Why don't you go ahead and give us a little outline of what we're going to see today, and you can just jump right in. I'll be watching the chat. I'll be kind of leading the discussion, making sure we get questions answered and so forth. But I really just want to kind of step out of the way and let you share your knowledge with us.
Okay, thank you, Brad. So actually what I will start with is a bit explanation what's the difference to design for standard processes like injection molding or machining and design for 3D print, because there is a difference. And if you know how ABS is acting when it's injection molded or machined, and you think that it will be the same when you print it, you're totally wrong. So this is first things that I will show. What's the differences and what you have to pay attention when you design for printing. And then what I'm going to show you is how you can modify a model just to have it for prototyping for the print without damaging your model, which is designed for other process. And yeah, more or less is that. I mean, it sounds like short, but it's a lot. And let's get started with the first model that I have here. So this is something that is designed for printing. I will now show the two parts. It's a okay. So it's a part for leveling my printer, because my printer is actually not so expensive. It's pretty cheap and it prints really great, but it was not sitting properly on my bed, and a lot of printers are on the desk and a lot of printers are having this issue. So I just printed a leveling for my printer so it can be perfectly leveled and I can have the best prints. What is the part here? Many people actually don't know you can print thread. Just you have to go threads that are more than 1 millimeter pitch and you will have no problems to print that. And what is the difference when you print for, when you design for 3D print and for a normal design? So usually if this part is injection molded, they will make the thread afterwards. And it doesn't matter how you will place it and where the thread will be. But when you're going to print this part, it's very important where exactly it will be sitting. There is this nice feature of SOLIDWORKS, which is Print 3D, and you can make a small evaluation of your model with choosing the bottom plane, showing the different layers. So if you choose this as a bottom plane, this will be wrong. On this thickness, it may work and you can be able to print it. But if you're printing a thin wall with a hole inside, there is a big chance your layer split at the moment you put inside this hole what should be there. So you should always consider when you're making such model that the hole should be done by the printer, like moving the head around and not having the layers like this because they can split. So this is one of the things which are very important. The other thing is when you're designing tiny walls, it's good to have some additional support here if the walls are not connected on some angle. Otherwise, there is a great chance this wall will just break down, especially if the layer is going like this. So if I will close just the 3D print now. Okay. If my wall was not like this, but like this, no matter that it's actually pretty thick wall, this is the recipe for disaster. It's 2 mm wall, this will break here. Absolutely 100%. It can be after day, it can be after a month, but it will break because the layers will just split. They're not holding so tight like when the plastic is completely melted and then let cool down.
So what would you do there? Would you put a fillet in, or maybe a rib or a gusset of some kind?
You can put a fillet, but actually the one thing that is working better is a chamfer. You just put a chamfer on the inner side.
Okay, so this is interesting. A lot of times we think about chamfers as a way of removing material, but here you're using it almost like a weld bead, like a fillet weld.
Yeah, and this
adding
is
material.
Yeah, and this is adding actually strength. You can put also a chamfer here, but the critical area is the one here. So here it will be more or less solid, but on the inner part it's stopping with one layer exactly here and starting with the next, which is pretty thin here. When you make the area a bit wider on the bottom, and it holds better.
Okay. And as I'm checking in on the chat here, it looks like we have a question. Can I give you a question, Danute, from the chat?
Yeah, sure.
So Mohammed is asking, we're talking about fillets here and chamfers. What's the biggest fillet that can be printed with a 0.4 millimeter nozzle? Is there kind of a rule of thumb? Is there some math you can do on that?
The biggest fillet that you can print. So actually you have problem usually with the smallest fillet. The biggest
right. It would be the other way
machine.
around, wouldn't it?
Yeah. The biggest depends more or less on the machine that you have.
Yeah.
And the way you print. So if it's oriented like this.
Or maybe I'm not sure, maybe Mohammed can follow up with that, but maybe he's talking about before support is needed. I'm not sure.
This is absolutely individual on the machine. There is actually, there are a lot of free models that you can test the capabilities of your machine. You can see the overhead that you can have. You can see the bridges your machine can do, because it's individual on each machine and the material and the operator, what actually the machine can do. And what I highly recommend is to find one such file. They're available free. Download it, run it on your machine, and see what you can do with it.
Oh, looks like we have a follow-up here. On the question is the biggest fillet that can be printed from the bed, so on the bottom plate of the print.
Yeah, exactly.
Yeah,
He's doing it like this, but it's actually the same. Always the lower part is a bit more crushed, but depends also if you have a good cooling while you're printing. So it doesn't matter. The angle and geometry is the same. It doesn't matter the size.
Got some good comments coming in on the chat. The tugboat model test. Yep, Matthew, I've printed that one too on my printer. So I'm sure a lot of people want to know what printer you're using today. It sounds like you have experience with a lot.
Yeah, well, I bet there are a lot of people that have experience with more than me, but at the moment, actually, I'm using Elego Neptune 2S. It's a pretty new printer. It doesn't have all the cool features that some of the newest printers have, but it has everything that I need. So it's a great machine that can print with really good quality. And actually, it can print an overhang of 85 degrees, which is amazing.
That sounds awesome. Yeah, when we were on just a few days ago getting acquainted, I think Andrew, our producer, and I were both really impressed by this printer. It wasn't one that is on our radar, but and I think Sarah behind the scenes is going to give us a link to that here too in the chat. So if anyone else is interested in the Elegoo printer.
So, okay, now We covered where to put the holes. We covered to be careful with layers. And actually, do you know that you can print different type of clips? Like
different types of clips. Okay.
Yeah.
Show me what you mean by that.
I will just make one right away. So I will go back here. I will play mostly with this model, I think. So let's assume you want to make a clip for a battery holder.
Oh, okay. So we can press fit into it.
No, not press fit.
No.
So even with the PLA material, which is pretty brittle, you can print a clip that is working, in which you can add something.
Okay.
What I actually do to make the best thickness because the thickness of the clip depends also on the diameter in this case. I'm blind. So let's imagine that we want to push something through here, like a battery or something similar. And the trick I do in this case is I just print few different clips with a difference of 0.1 in the thickness. And then you can see which is the best one, like a hold and flexibility. And you can do this even from PLA. Recently, I needed to work with this material and make a clip. I didn't believe it will work out, but it worked, and actually it worked pretty well.
Oh, interesting. So you're doing some trial and error then by making a few different models with different thicknesses and printing them all at the same time. Is that right?
Yeah, it's that. And actually, there is also another thing which I didn't mention, but it's kind of important. Not always you're printing on your own machine. So if you're like me, a freelancer, sometimes you have a customer that has his own machine. And as I said, it's very individual for every machine. When I build my models for my machine, I know my machine and my machine tolerances. But when you are building a model for somebody else, you should find out their tolerances. And it's getting a bit tricky. And what I'm doing is actually, let's say this clip, I will make another part. Okay. I make two parts close to what we have. And usually here I will put a number. And so I make one with the distance 0.2, then I make two with the distance 0.3, and so on. And I send him like 4 different models and ask him to print that and to tell me which one is actually fitting best. And when he tells me, for example, 3, I know that 0.3 is the gap that is working best on his printer.
Okay, so you're doing a little self-calibration there. This is interesting to me because I'll do something like that too. So I'll go run a little test print just to get my sizes right. Maybe not even printing the full model. Maybe it's just a little piece of it. But I hadn't thought to print all my iterations or a range of iterations all at once. That's a clever tip. I'm going to steal that. Yeah. So I've got a couple more questions here. Let's see. It looks like Noah is asking. Okay, Noah, you are our resident expert here, but you're asking, are there any special print settings for printing thin threads? So Danute, you said that you need to make sure you're bigger than 1 millimeter pitch, but are there any other tips for printing thin threads?
Yeah, you actually can print less than 1 millimeter pitch too, but I would not recommend to print anything below half.
Below half, okay.
If you're going below half millimeter, really, I would recommend just print a hole and cut the threads, because usually this is a small hole. When printing less than 1 millimeter, you should stick to the lowest possible layer height. So the smaller the thread you want, the smaller should be your layer height.
Okay, good, good. So that kind of follows up with one of the questions I see here in the chat about what the parameters are that are affecting some of these tolerances that you're talking about here. So you have layer height, you have, what are some of the other parameters that we might want to make sure we're acquainted with?
So actually the layer height is not affecting that much. It's affecting the outer shape, and it's affecting your model if it's not straight. I mean, if your model is straight like this, it doesn't matter what's your layer height. For the tolerances too, it will have a minimal effect. But the temperature, the thing which is affecting most is the temperature in the material itself. And the setting is that you should find it out. It really depends on that. Sometimes when you want something that it's more precise, you should find the lowest temperature that you can print on without having the layer split. And then it will be more precise. The bottom layer is usually a bit wider than everything else because of the hotbed. If you don't have hotbed, it's also wider. I mean, you smash a little bit the filament in the bottom layer to stick. But what really affects the tolerances is the material and the temperature and the ability of the printer to control well this temperature of the nozzle.
So you showed us the Print 3D screen a little while ago. One of the questions that I'm seeing coming is, can SOLIDWORKS do the slicing for us? Like, can we visualize the layers from within that screen? Or do we need to go maybe to some external software?
So you can visualize the layers that I was about to show, but I want to show it on a bit more complex model.
Okay, tell me about this model.
So this model is actually, this can be printed on my printer. As I said, it depends on the qualities of your printer without any support. So, and I can check in SOLIDWORKS if that's true. I said my printer has an overhang of 85 degrees. And we go to Print 3D.
To Print 3D.
I'm going to Print 3D.
Yeah.
Here you can choose some printers. Mine is not available, so I just pick a custom printer. Choose the bottom plane. In this case, it will be that.
So this would be the orientation of the bed.
Yeah, this is where the bed is sitting. So if you want to scale it, here you can scale it too. And if your printer is here, I think that you can literally print from SOLIDWORKS, but I never had a such printer, so I cannot check. Because here you have printer properties and job quality and support and draft. For checking purpose, you go on Preview tab. And you can hit here, Show Faces that require support.
Okay, and then here's where you put your support angle. And this is just what you would know based on your printer.
Yes. And I know that my printer is printing without any problem. So a perfect face to 75 degrees and a bit rough face to 85 degrees. So I will put 75 because I want this to be beautiful. And when I look on the model, I see that just this here are more than that.
Tiny little bit of support is all that's needed right there, huh?
Yeah, but then I will go to, when I go to 80, I see 80, that it will print
support.
No support. If I have a worse printer and go to 65, for example, you see I need a lot of support here.
Yeah, and so the support, then that means that there's going to be some cleanup, some post-processing. It's not going to be maybe as smooth.
Yeah, but actually with this tool, it's really a really great tool to check your design, because you can modify it before you print and before you see that you actually need that support and it's not looking nicely. And with the test print, you can know exactly how far you can go with the angle. But that's really great tool here.
Okay, so the support angle, then, that's really printer dependent, it sounds like.
Yes.
Yeah. Okay. And that's so Mohammed, I think that answers the question about your negative angle. It's going to be dependent upon your printer.
So, and here when we go a bit lower, we have this show striation lines.
Striation lines, okay.
And you will see actually how the layers will look like.
So these are the actual layers then, based on your layer height of, I see, what, 0.3 millimeters?
Yeah, 0.3. Right? Yeah,
okay.
I leave it 0.3. So this would be a rough print. And wow. when you go lower, they will change, they will adapt.
Yeah, that's amazing. It's like a print preview.
Yeah, that's print preview. Exactly. 3D print preview.
Now, if you had a supported printer, could you actually generate the G code, or you still just output the STL from here?
I never had a supported printer, but when they presented this feature, when they included a few years ago in SOLIDWORKS, I think they said it will be able to directly print from SOLIDWORKS.
Yeah.
But I never tested that.
That was my understanding too, is that it can print directly, but what I'm not sure of, and maybe that's what the questions here in the chat too, chime in if you remember this or if you know about this, but I'm not sure if we can actually get the G code file itself, like it could transport that to another printer.
No, the G code you cannot have. This is just for printers that can be connected with the computer through USB, and you can print directly through USB with drivers.
Okay.
It's not a slicer software. So what else we have here also in the tools is thickness and gap analysis. Another cool feature. You can choose the material and you can hit that, and it will calculate based on your layer height and your material what is the optimal gap and thickness. And you can here change the sensitivity and calculate. That's why I picked this model, because this model is not perfect. And it will show you where the gap is too small and where the material is too thin for that print.
Mm-hmm.
But again, even with this information, especially for this model, which is actually a container for pine nuts, for me, doesn't matter. This will not affect the end product when I print it. In some cases, it could be really important information that the gap is too small, because you have a chance to close it.
Oh, I'm sorry.
Yeah, because there is a chance when you print it, this gap is just not existing when it's too small. So there won't be a gap if it's too small. So now you can ask your question, Brad.
Oh, I was just going to ask. This is a container for pine nuts.
Yeah, this.
So it's a pine cone that. So it's like it's got a lid, or it screws off. Is it threaded? How does it work?
This one is not threaded. It will go out from the 3D print. So I will just hide the lid. It's a lid. No, I had the other part. The lid has a small channel to fit inside without sliding sideways.
Okay. And you can print both at the same time?
One on top on another? No, they will be just glued together. But you can put them one next to other, and they can.
So you'll lay them up side by side on the bed.
Yes.
Mm-hmm.
Usually this is what I do. So this is the lower part. Of the container, and I will make a section. Here it is.
There we go.
So this is how it's looking. And
so tell me about your process then for getting this to the printer. Two separate STL files then, one for top and bottom?
Yeah, the process is pretty simple. SOLIDWORKS has a lot of tools for modification, which are great. You just make delete body, save as STL. Then I edit. I really even don't put second feature because I'm lazy in this case. It's private project, and just change them.
Yeah.
And save the other.
Or I suppose you could do a move body and move the lid down to the base and output them both in one file, couldn't you?
Yes, I can do that, but the slicer
probably a
that
little
I'm
more work.
using before was able to separate two files when they're together in one.
Mhm.
At the moment, they change something, and this is not anymore possible. And if I don't have a lot of time, or I don't want to start a long print, I can print just the top, or I can print just the bottom. Or for example, the top failed and I want to print it again. There is no point to have the two files in one. It's better to
Okay.
print them. If you want to print them together, you can always set up the printer to print them together this time for this job. But it's good to have a separate file so you have the freedom to choose what you want to print.
Okay. Yeah, that's a good tip. I guess that's a consideration I hadn't really thought of before, but something to think about if you're printing multi-bodies, whether to use one STL file or make it a little more modular with two files. Trade-offs either way, I guess.
Yeah.
Ashish, hope I've got your name right there. Any metal-related material to print our machinery part? Any metal-related material? Not sure I understand that question all the way. We're talking about FDM, which is primarily plastic-type materials, correct?
Yeah, but actually I understand the question and I can answer that. So
you can be my guest.
there are now there are existing FDM printers which have reinforced plastic with glass fiber. It's still plastic, but the manufacturers of these printers claim that the material is as strong as metal. So you can use it to make prototypes for metal parts and test them. I have had samples of such prints, of such printer, which is reinforced, and yeah, that's unbelievable, the strong material. So I never tested on real machine to see the readings, but I believe they're really, really close to a metal one. So these are special printers. They have two filaments. One is the plastic, which is special plastic, and the other is the glass fiber, which is reinforcing it.
Yeah, and yeah, those are definitely a pretty popular platform these days. I think we have a number of resellers that are carrying that technology too. Yeah, so threads and tolerances really seem to be on everybody's mind here in the chat. Can I give you a couple more questions, Danute?
Yeah, sure.
So what are the max and min tolerances of a 3D printer?
So if you have a really, really precise printer, the tolerance for the gap could be 0.1 millimeter.
Okay.
So there are such FDM printers which are in the low budget range that can print that good. Especially if you print slow, if you have calibrated well your machine and you have picked the right temperature. For the max one, I don't think I have seen something with more than 0.5 millimeter. So it should be somewhere around there, 0.1 to 0.5 millimeter.
Okay, and how about a question about threads again? If you design a nut and a screw, how much must the gap be to make a perfect fit into the thread, into the spiral?
So for my model, I will go back to that. And yeah, I will just delete what I added inside. For this particular model, maybe it's good to delete also the sketch. I made it, I think, with 1 millimeter gap between the two. And I have used the standard thread, which is here with the thread wizard. I mean, I didn't build it by myself. I used just the standard thread. You can see it here, thread 1 and thread 2. But always you can make just a small part thin or thick enough to check with inner part and to go back again with this checking with going 0.1 smaller, 0.1 smaller until you find the best fit. This one I made it from the first shot. I just made the inner circle 1 millimeter smaller than the outer circle, and it's fitting perfectly.
Okay, good. So I hear one millimeter sounds like a pretty common number for a lot of your testing and a lot of your baselines.
I have another number, but it's hard to print and it's not for everybody.
Okay, very good. So you showed the thread feature, by the way, and I just want to make sure our SOLIDWORKS users out there are aware that you're using the thread feature built into SOLIDWORKS Desktop. 2017, folks? Tell me in the chat. I want to say it was around SOLIDWORKS 2017 that this feature came about. And some of you may not know this is here, and you're still creating threads by the old-fashioned way of creating a curve and then doing a sweep.
So that feature was a life changer. That was a life changer. I mean, at the moment they released it, I loved SOLIDWORKS. Not that I don't love them normally, but this was the one that I needed the most because I'm doing also a lot of renders, and you have to model the thread for the renders.
Yeah.
By the way, I can check the gap. I said it's 1 millimeter, but let's check it.
There we go.
We have great tools.
Measure tool.
We have great tools here. No, 0.5 millimeter is the gap. I lied. Oh, 1 millimeter in the diameter. So.
Yep, 1 millimeter diameter. Exactly.
Yeah. So when you go here on the thread feature, on the whole wizard, on the arrow, you have this thread. I mean, there is also strut wizard. This is pretty new. You hit that, and it warns you that these are nominal values and you should not use it in your design. But I do use them in my design, and they're working great. So you have to pick a circular edge or sketch. In this case, I have this edge. When you pick it based on the diameter, it will make some, oh no, actually it will take some of the last I was using.
Remembers your last size, good.
Yeah, I think it's taking, because this is really big hole, it's definitely not M4, it's diameter 30. So, but you pick from here the size that you want, if it's a standard size, but if it's not standard size and you just have some hole in which you want 1 millimeter pitch diameter, you're just searching something with that. So M10 has 1 millimeter pitch, and I will just pick M10. Then the other thing which is good to make is to make an offset. By default, it will go, I don't know why it is going inside the thread. You have to reverse it to the opposite direction. And when you're using one, you have to choose at least 2 as its offset. The second thing,
you're trying to run the thread out into the air a little bit. Is that right?
Yeah, otherwise here you will have edge stop of the thread, and it will not be through all, because it's starting with the edge itself.
Okay, that's a good tip.
Yeah, and in this case, I will be cutting the thread. So it's okay to make it like this, but when you're extruding the thread, then you have to go here and give trim with start and end face.
Okay, so that's what takes care of the offset then.
Yeah, that's what's removing the extra material, which will be after your edges. If you're extruding.
Very slick.
So here you have also start end condition. You can choose if it's spline and some size, revolution, or up to selection. I will just leave it like this. Usually I do the thread always longer than my hole. So starting before, ending after. Otherwise you will always have this top from which it's starting. And it's not exactly correct.
Okay, very clever, very clever.
And if you need a certain length and you have used offset, you should hit here, maintain the thread length. Otherwise, when you offset to 2, it will continue just 8. This is when it's natural.
So that's measured from the offset. So you got to make sure that if you're using a blind value that you run it out past. Okay, that makes sense.
Yeah, so they have to think about everything in this operator. So here you have, is it top, is it die? And if you cut or extrude, in this case, I'm not sure if I'm in the correct orientation. No, I'm not. So if you look here on the sketch, I will make it. Okay, so the sketch is going in that direction. So it's wrong. This means you have to switch to tap.
Yep, it's a tap this time.
and as you can see, it rotates.
Always look at the preview.
So you have always to check that. And more or less, that's it.
Yeah.
You can locate your profile, you can rotate it by some degree. There are different options. It's a nice operator to play around.
Yeah, and I've done a little bit of printing some functional threads with this, and I've really found it to be really reliable and easy to use. It looks like you're making a lot of use of it too.
Yeah, I am. It's really comfortable. A lot of people are avoiding to print thread. It's hard to print, but actually it's not so hard. Even if you're thinking that the thread is having a big overhang, actually it's not. So it's, and now I'm going to show that.
Okay.
So we will, okay, here I have two bodies. I was not lazy here. We're going to print 3D. Choose it here. I will just rotate it like this. And we go to the preview. So if your printer is able to print overhang of 60 degrees, you can print thread.
With no support. That's awesome.
And actually, this is a value that every printer that was produced in the last 2 years should be able to do. For sure. Yeah. So
quick check-in on the version and instance of SOLIDWORKS that you're using here.
So I'm using SOLIDWORKS for makers. It's actually the latest one. Hello. So here it is. There was a hotfix today, so it's really the latest one.
Yeah, you're definitely the latest. 2.6. So 22x is how they the nomenclature then for 3D Experience SolidWorks. So this is the maker version. I think we'll have a link coming up in the chat if anybody's interested in SolidWorks for makers, but it's basically SolidWorks desktop, right? It's just that it's always the latest and greatest version.
Yeah, actually, it's amazing. SolidWorks Maker is corresponding more or less to the professional version of SolidWorks. It's even not the basic. And you have all the great tools. Okay, you miss some, but with this version, you can do literally anything. And if you're a big fan of SolidWorks or you want to learn to use SolidWorks, I totally recommend having this SolidWorks for makers. It's ridiculously cheap to have. So, and you have all the power of SolidWorks. It's just great. There's some slight differences, but just as modeling operators and features, always there that you have in the professional. And yeah, that's great. Great thing that the Sol system released this Maker edition for the fans. I love them for that too.
Yeah, I think you make a good point too. I mean, the reason that we're even having the session today is because I think a lot of folks recognize that 3D printing is one thing, but to really do it well, you've got to have tools to prepare the models for 3D printing. You can't just go download a lot of STLs and start printing stuff. You're going to run into trouble. And there are tools that you need that are kind of purpose built for, like this thread tool, for instance, or like the Print 3D analysis tools that help you design for printing.
Not only this, because Brad, great that you mentioned the downloaded models. I'm not building everything by myself. Sometimes I also download models and use them. And for example, I like something, I want similar thing. It's complex shape done in some mesh software, for example. Things that are done in mesh are usually hard to SolidWorks unless for X shape, but I don't have experience. I mean, you need experience there. And you have all these great tools in SolidWorks to modify and to repair imported STL, because you can download a great model that you cannot do by yourself, and you realize that this model is broken and you cannot print it properly. When it's broken and it has broken faces, you will have gaps in the print. So in this case, you definitely need to use some of the repair tools. I will open this STL file.
Oh, okay. Now we're getting to the interesting part here. I was hoping you were going to get to this.
Okay, so when you have the STL import, I just imported it. It imported as a body because this is the settings that I have done for myself. But probably most of the users have a standard setting to import a graphic object. Or there are 3 different ways you can open an STL. So I will go to open again. Just I will not open this time. Here, when you hit options, this way, you will see what are your settings. Is it a solid body, surface body, or graphic body that you will import? The problem is with very complex shapes, you have to go to the graphic body, or you have to simplify the shape before that. If there are a lot of triangles, it will just stack. But by meaning a lot, I'm talking for hundreds of thousands triangles. Everything below that should be importable. So here you can pick the different ones. And if you import a graphic body, you won't be able to work with it because it's a graphic body.
Yeah.
But SOLIDWORKS has you covered also here. You go to Tools. So actually insert, I'm sorry, Features. And you have here Convert.
Convert to mesh.
Convert to mesh. And then you have a solid body and a graphic body, but it's hidden. And with this now you can work.
Okay, so what are some things you could do to this this mesh body at this point?
So let's go to the top. Okay, so a little bit. Tangent. Well, not tangent. Let's just make some crazy shape here.
Okay, so you're putting an extrude on top of the existing mesh body.
Ah, okay, yeah, but I'm failing with some face.
Failed to merge for some reason, but
yeah,
that's a great use case, right? You download a part from some online content. You need a hole to be bigger, or you need an extra mounting boss or something like that. You can do that through these.
Yeah, you can delete the face, for example, convert it to surface. Then you can extend.
There you go. So just a little manual repair.
Yeah, you can extend the surface, for example, and you can extend all of them, and then again put another on the top and make everything together. I mean, you have a functional model, and you can work with that. But with the graphic object, you cannot work. It took me really a few days until I realized what was the problem with the graphic bodies I was importing. The graphic body, a lot of people have asked me before why I cannot work with the graphic body. The graphic body is not actually a body. It's a visualization of the model only. So
just a bunch of triangles, right?
It's just a preview. Let's say it like this. It's like you're looking on 3D picture. You can do nothing with it. You can just look on it. Maybe you can measure it or something like this. Yeah, you can measure. But you should accept the graphic body as three-dimensional picture inside your model.
Yeah, great analogy. I mean, we would use that sometimes, like say in a really large assembly layout. You might want to, just for efficiency purposes, you could have graphics bodies in there because they're very, very lightweight. And really all you need to do is visualize maybe a space envelope or something like that.
Yeah, that's a great way to use a graphic body. But the point is that a lot of users, when they import, they don't know they import graphic body, or they cannot import something else. As I said, with a lot of triangles, you cannot import surface or or solid. I had this issue a long time ago when I was changing jewelry. So you can imagine how complex shape is that, and you just cannot import solid or surface. You import graphic body, and then you can convert it and work with it.
Okay, makes sense. Let's see. Ben's got a question here. He's talking about functional parts. Do you find yourself adding tolerances to dimensions just by intuition, or do you use equations that you can come back and edit later, maybe to make a parametric type of part?
So as I said, I know my machine, so it's not intuition. As a rule of the thumb, on my size, and on any size actually, the inner holes are shrinking with approximately 0.2 millimeter on the side. And the outer walls actually are also shrinking. So these are the things that you have to consider. So when your inner hole is getting smaller, on the other part that should fit in this hole, it's also getting smaller, but the outer shrinking is less than the inner one. The outer is about half of it. The
Interesting.
rest, yeah. So when your inner hole shrinks with 0.2 and your outer part shrinks with 0.1, it will just not fit inside.
Okay. So there's a little bit of GD&T that you're kind of doing intuitively there, isn't there? For max material and min material.
It says intuitive. Yeah, well, 9 years printing.
Yeah. So that sounds like something, if you do know that that's a ratio that you can kind of rely on, you could parameterize a part where if you wanted, say, to make a family of sizes, you could make the OD shrink at a smaller rate than the ID. That would be a good use case for equations, it seems to me.
Yeah, definitely. You can use these equations for that, and you can definitely predefine the materials. As I said, everything is depending on the machine too. I mean, there are some standards, but it's depending on your machine. You can make a test print with holes. I mean, most of the test prints, they have different sizes of holes.
Yeah.
And there is a reason they have different sizes. They don't have one.
Great
because
tip.
On 1 millimeter, when you're printing 1 millimeter hole, actually, I think you cannot print 1 millimeter hole. It will just, there won't be a hole.
Yeah, it's within its own tolerance. So that reminds me of a video of yours that I watched on your channel, D-Workshop, by the way, everybody. There's I think we've got a link to Danute's channel, but you made a knob that sat on top of a hex bolt.
Yes.
And you parameterized it, so if you change the size of the bolt, like say you get a different instance from the toolbox, a different size family, then the knob will automatically size itself up.
Yes.
Yeah, that was a really cool piece of content, because I find myself doing that a lot. I make little knobs and things to put on top of fasteners, or improve on a design or something.
I do believe that many of the designers were through that at one point or another, when you need a knob and you don't have a knob, or you need something specific. And I find this is the easiest way. I mean, you can print your knob and just place a bolt inside and you have a knob. That's easy to use.
Good. Oh, I brought up GD&T, so I guess we've got a question here. Good resource for studying GD&T. Have you done any GD&T resources? Have you taken any classes in that, or?
To be honest, this terminology is something I have seen, but I don't know it. I'm not a native English speaker.
Okay.
So okay to tell it along.
Well, I'll take that question then. Geometric tolerance, geometric dimensioning and tolerancing. There's a couple of us. Andrew, our producer, has taken a class on that. I took a class a few years ago. I did an online class for anybody who's in the chat and interested in that. I think it was through, I believe the resource was called I Get It, i.get.it. I'm sure there's lots of good resources, things like LinkedIn Learning, probably YouTube these days, but a lot of good resources out there for learning some basics of GD&T.
Yeah, for tolerances, a special class, no. I was learning the tolerances, the different tolerances with the work in the different fields I was. And yeah, you should really look for what you're doing for your area of expertise, because they differ greatly. I will just drop inside here, for example, something which is not related so much to SolidWorks and mechanical design. This is the PCB. I have some background also in that, and usually you work often with electronic engineers. And the PCB tolerances, they're really tight. And I don't know if you have seen sometimes a mechanical box done by electronic engineer. They use the PCB tolerances, but these PCB tolerances for the mechanical manufacturing, they're almost impossible. I mean, you can do it, but it's not needed. So.
Well, so it's obvious that tolerances go hand in hand with designing for FDM. Now, Danute, we've got maybe about 5 to 10 minutes left of the broadcast here before we spill over. I want to make sure you've got plenty of time to cover any other topics that you wanted to share with the audience. So take it away if you want to pick up where we left off, or maybe switch gears.
So yeah, actually for the tools, the cool tools I explained, for the imports I think I explained, I can now just show off some stuff which I have printed, if you want to see.
Yeah, let's see what we've got here.
So you already have seen this. So yeah, I don't know how it's looking on the camera, Brad.
Okay, so this is the pine cone container. Look at that. The
pine cone container, and actually it's full with nuts. A good thing to mention here, be careful what plastic you're using for food. I mean, not every plastic can be used for food. You should be careful with that. PLA is normally safe for food. PETG is normally safe for food, but they can have a colorant or which is toxic, so you should check with the manufacturer for that. And I wanted actually to show a picture, I think. Where was that picture? Which I wanted to show. Okay, I forgot something. Yes, that's good. I went to the pictures. Do you know that actually you can use the SolidWorks to make a surface rough like this?
Okay, tell me more. I'm not sure what I'm seeing here.
So this on the right side, as you can see, it has some rough surface, and the left side is a normal print. And this rough surface is done with 3D texture.
Okay, now I'm interested. 3D texture.
So
circa
3D texture.
BZ, what was that? Zayas in the chat here. He can tell us when that came into SolidWorks.
Okay, so 3D texture is really cool about that. And I found it out after using a professional SLA printer, which was supposed to have this option to make a texture of surfaces. But it turned out that this option costs additionally a lot. So we didn't have it in our software. And we were kind of disappointed. But then I found out the 3D texture.
3D textures, yep, right there in the task pane.
So here are the 3D textures. You pick some.
Okay, everybody wants to do knurls, so that's right there, or maybe a dimple pattern or a diamond plate. Oh, look at all this.
Yeah, there's stars there. But I actually wanted to show how you can do it with your own picture. Okay, well, I'll take the knurls.
This is true ninja level, right? Matthew's chimed in with that.
So some standards are pretty cool. Okay, I will just make 2. Let's make it fair.
Oh, diamond plate, yeah.
Oh, I will change the diamond plate. Okay. So when you go to the diamond plate, go edit appearance. Go to advanced. And here you have image file path.
You're just going to swap out the image.
You go out of here. I go just to my, to which pictures I'm going. So
you want a nice high contrasting image, if I recall.
I think I will steal something from Visualize.
Yeah. Honeycomb. Okay. Look at all this. This is awesome.
Yeah, Yeah, so I will take what? I will take that. Okay, just leave it like this. So we have the diamond on one side, and this, you will see this is actually looking pretty cool. Then we go insert features and 3D texture. Pick our model, and you can see here you can choose one by one if you want them with different settings, but I would choose just both of them. You have an option texture refinement. Usually for more raftings, approximately 50% is okay. Here you have the offset distance, so how tall to be, and the maximum element size. This is controlling how precise it will look like. You should be careful with this too, because it can become really hard to work with the file if you go too far. So this is one side. Going a little smaller. Okay. Now I think this looks interesting. You can convert it also, white up, black down, or the opposite. And I have set up just this part. Now I go to the other. And we have the settings for the other side. Okay.
Oh my, look at that.
And then just hit OK. But you will end up with a graphic body. And we already know how to turn a graphic body to something printable, right?
Right. We turn it into a mesh body.
We turn it into a mesh body.
2019, says Michael Steves. 2019 for the 3D texture. I can't believe this. It's been in my software for all these years and I haven't printed one. I'm going to do it. I'm going to do it this weekend.
The important thing when you're using 3D texture and something really rough as a side, it should be on the vertical side. So your print bed have to be here or here. Or
okay,
here.
So don't try to print it flat. Print it.
If you print it on the top, that's image number 2. Where's my... I really hate when I lose my slides. No, that's the pine cone. See how bad it's looking on the top?
Yeah, yeah. Okay, so, great tip. Great tip, everybody. If you're going to print the 3D textures. I love this. So Danute, it's the top of the hour here, which is officially coming in for a landing. Everybody is still super engaged in the chat, and I know it's getting late where you are. Do you want to hang out for another 5 minutes or so, or should we start wrapping up?
So I can hang out for 5 more minutes. So
okay,
if there's some questions.
Let's go to the big finish. As if the printing 3D textures wasn't enough. What's kind of the finale, the grand finale of what you had to show us today?
I was about to show some prints.
Yes.
This little thingy I call the unprintable.
The unprintable.
The unprintable. Actually, many people cannot print that, but it's not so hard to print when you know what you do. When you want to print some tiny little pieces like the seeds here, you just have to print a lot at once. Okay, these are not on enough distance one from another because it was fast print. But if you need to print something really tiny to work, you have to place something else to be printed with it. So you have a time for the layers to cool down. Otherwise, you will have just a messy, melted thing, not a shape.
That is such a great tip. I never even thought about that before, but just print something else with it.
Yeah. Oh. And another trick when you're printing small things and you would like to preserve the temperature, while I'm still here, I will just make it around this one. You can always just make a wall around your model.
Okay, and so some sacrificial geometry. Just
yeah. You print a wall around your model, so not bidirectional, please.
Just a thin feature extrude or an offset sketch, yeah.
Yeah, thin one with the height of your model.
Everybody knows how to do that.
Everybody knows how to do that, for sure. I will just stop it here.
So you're just really giving the printer something to do while the main design model cures.
Yes, and in this case, this is actually to protect the heat in. I mean, if you don't have enclosure on your printer and you have some sensitive design, just print it a wall. I mean, you can do that.
Wow. Wow. Look at all the wows in the chat. Sean O'Neill, wow. Snaptrip, wow. Noah, super cool. Yeah, these are really some valuable tips. This is awesome.
So, yeah. I think
so. Show us the dandelion once again. So very easy to grow. My yard has a bazillion of them and I can't stop them from growing, but really difficult to print. And this is kind of like your signature print, isn't it?
Yeah, I think you can tell that. But you know, actually in GrabCAD, but I didn't give a link for that. In GrabCAD, you can download the files for the print. You can print it yourself. And there is a video explaining how to do that.
That's really awesome. I'll bet we'll see a lot of downloads for that file. But the fact that you've taken the time to, I guess, to get to know your printer, that's one of the big takeaways. Really get to know your equipment so you can maximize the capabilities that you have, and then take the time with lots of prints, doing some trial and error. And then coming up with some of these really great tips, like giving the printer something to do with some other geometry, or building a little temperature enclosure around your model. Some really awesome things that you can do. And I love how you've taken advantage of some of the great features that have come along in the software, like the threads and the print to 3D, the 3D textures. It sounds like you're really getting the most out of your expertise and your equipment. So. Danute, awesome content. We're so glad that you were able to share all this with us. One last parting thought for the audience, maybe, before we wrap up.
Yeah, the parting thought, another thing I missed. So when you don't want to damage your geometry when adjusting for your printer, just use move face.
Move face.
Add move face after your original design. Adjust it for your print. Then you can suppress move face and your original model is intact.
Exactly. Yeah, great tip especially for doing little trial and errors. I just need to nudge it a little bit or maybe expand it a little bit.
Yeah.
And also a great tip if it's a model that you imported maybe from a step file or IGES where you don't have a dimensional parameter to edit.
Yeah, exactly.
Do that for you. Yeah.
Very good point.
Great tips. Okay, so D Workshop is where everybody, I'm sure, has already subscribed to your YouTube channel. We've got the link to your LinkedIn profile. You're probably going to have a lot of new contacts here. This is awesome. And Sarah's gone ahead and pinned that in the link. Let's see, what do we have coming up on some upcoming episodes? I guess let's go ahead and promote what we've got next. On June 15th, everybody, you're going to want to tune back into YouTube for Manufacturing Live. That's going to be with Chris McBain, many years of an industry expert in CNC 3D printing. He's going to be on Manufacturing Live right now. I think he's at HP and heading up the additive manufacturing at HP. So make sure you check out that episode. And then the next day, the 16th, is SolidWorks Live. So my buddy Sean is going to have Marie Blanchard as a guest. So you know that the energy is going to be super high on that. They're going to be talking about best of STEM. So all the great stories of SolidWorks in education over the last little bit of time. I'm sure that's going to be an awesome episode. And I guess I've got one more plug to make here, and that is Dan Wagner. You have a user group function that's going to be happening. It's a tour, actually. If you're lucky enough to live in the Southwest U.S. like me in Nashville, Iron Swug. We've got a couple of SolidWorks champions and user group leaders that are going to be making a motorcycle tour around the Southeast. I think they're stopping at 5 or 6 different cities starting on July 18th. So we'll have I think we'll get a link to that in the chat, but look out for Iron Swug, or if you're in the Southeast US, you're going to want to get to one of those live events, not to be missed. All right, everybody. Well, thank you so much for joining us today for SOLIDWORKS Live Design. I cannot wait to try out some of these new tips on my 3D printer. If you've got a printer or have access to a printer, you're going to want to try out some of these tips. And yeah, let us know maybe in a future episode if you get in the chat, tell us what you've been doing. And thanks again, everybody, for joining. And I believe that wraps us up. We'll see you next time.